Hello, everyone. Welcome back to SAT Math Question of the Day. Let's just get going right to our SAT Math Question of the Day. Please look at it, try it yourself, pause the video, come back, and we will go over how to do it. Okay, so here we have a circle in the xy plane that has a diameter. Which of the following equations is the equation of the circle? Okay, so it doesn't hurt to maybe 0, 3, and -4, 0, and then you have to figure out what.
No. Wait a minute.
Oh, you're right.
0, 3 has an x coordinate of 0 and a y coordinate of 3.
I always mess that up. Wait. 0, 3, and then -4, 0. Oh my God!
Yes.
Thank you, Seth. I always mess that up, and
bet you would have gotten the question wrong if you.
And I bet that answer was in there.
Okay.
Oh, wow. Thank you. So then you have to know what the general equation of a circle is, and this is something you probably should know going into the SAT. The general equation of a circle is x minus h squared plus y minus k squared is r squared, where hk is the center. So.
Okay, so what do you want?
So there are different ways to do it. I mean, it's helpful to know what the center is. So wouldn't the center there be the midpoint?
It's the midpoint.
Yeah, the center is the midpoint. So then you have to know.
What's the input? The midpoint. Each coordinate of the midpoint is the average.
Right. Yeah.
Of the coordinates of the endpoint.
So let's write that down. Xm, ym. The coordinates of a midpoint of 2 points is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So it's just the average of the x's and the average of the y's. So the average of the x's is, -4 plus 0 divided by 2, which is -2. The average of the y's is just 1.5, right? So now maybe if we're lucky, these two have the same center. Sure, of course. Using test-taking logic, one could have even realized that the answer is probably going to be between these two, because these have totally different centers. So you would think if you were test-taking that you would give the answer, you would have the answer. You have two answers with the same centers, but different radii. And notice one of them is square of the other. Do you see that? One of them is square to the other. This is the radius squared. So we have to figure out. What the radius is, and then we have to square.
Well, you could check it out by substituting one of the points that's on the circle.
Right.
0, 3. So let's make x be 0. 0 plus 2 squared should plus. See, the y is 3. 3 minus 3 halves squared equals the radius squared. And we need to determine, this is the mystery number, right?
Right.
And so let's calculate the mystery number. It's 4 squared plus, let's see, 3 minus 3 halves. That's a mess. So that's 6 halves minus 3 halves. It's 3 minus a half of 3 is 1.5, which is 3 halves. Okay, and now we notice, it's an integer. Anyway, let's just calculate it. It's 16 plus 9 quarters, right? And so it's a fraction. It's a mixed fraction whose denominator is 4, so it should be that. Right?
Right. Yeah. Yeah. So I noticed that there are two ways to do it.
No, it's 2 squared. 2 squared is
It's 20.
Not 16.
It's
4 is 4.
It's D.
I made a calculation problem.
It's D, isn't it?
Yeah,
Yeah,
yeah.
the answer is D. Now notice that I did it an entirely different way. Seth did it a very smart way. I did it a more probably straightforward way. What I did is I tried to calculate the radius, but I realized that this
Oh
is
yeah.
a Pythagorean. This is a right triangle. You can make a right triangle. You only care about r squared. So if you make a right triangle and you label what the distances are in the right triangle, you can calculate the hypotenuse, and you don't even have to take the square root. It's just you would look for r squared. You see,
Yeah.
the Pythagorean theorem says r squared, this r squared plus 2 squared plus 3 half squared. Oh no, r squared equals 2 squared plus 3 half squared. That immediately gives you r squared, which is there,
Which
which
is
is
a
clearly
yeah.
greater than 2. See, this 5.5 is only 2.5. No, 5 over 2 is just 5, 2.5. So this is 4. So you don't even have to calculate it. You know it's this one because it can't be that. I'm
Yeah.
not sure which one's faster. I noticed, I'm sure everyone realized that I was making a million mistakes labeling this as 2. Because again, people probably know by now I get my left and right confused, my up and down confused. So I had to really, but I knew I have that weakness. So I really had to think carefully, what is it? Is this side, is the bottom 2 or is the height 2? And eventually I figured it out correctly. But it took a while,
Yeah.
as you could see. While Seth was talking, I was just doubting myself and thinking about it. So yeah, so Seth, you're right. You just use the idea that if you have a function, you have an equation, and a point goes through the graph. That point has to satisfy the equation. Is that what you would use? That's what you were using, right?
Yeah.
Wait. So what did you do? I see. So you plugged one of these points in to the equation to see which one of these equations works. Right?
Yeah. That's what I did.
Yeah. So that's a really clever way of doing it. But you have to test each one. Oh, no, you don't have to test each one. You could just plug one point in and see what it is.
That's right.
Right. Yeah, so that's a little faster. That is a little faster, isn't it? Sure.
Yeah.
Yeah, that's much faster than the way I did it. Yeah. But in the end, I actually, with all my making mistakes, I actually got the answer faster than Seth. Right?
Yeah.
Yeah, I got the answer. Anyway, okay, so what do you need to know here? I mean, well, first of all, you need to know the equation of a circle. The general equation of a circle, that's absolutely critical. And you have to know the midpoint.
In terms of the center and the radius.
Right. You also
That's the form of the general form in which the center and the radius are read off from the coefficients.
Right. And you also have to know
the general. There's another general form for an equation for a circle,
Seth,
which is this.
Seth,
x squared plus b. Another general form of a circle is x squared plus y squared plus b x plus c y
equals
plus d.
Yeah, equals d. Plus d is 0.
Yeah.
Okay, but we're not going to talk about that.
But
the other thing you need to know about a circle is the definitions. You have to know what an endpoint of a circle is. Okay? You have to know what an endpoint of a circle is, and you also have to know what a diameter of a circle is. Because if you don't know those definitions, then you're not going to be able to pull the question together. So,
I mean, the center, not endpoint of a circle.
Well, it says the endpoints of the diameter. No, the endpoints of the diameter. Sorry.
The end. Oh, yeah. So how do you find the center of the circle given the end points of one of the diameters?
So I'm just going to erase everything. Yeah.
Yeah.
There's a circle. There's a diameter. Goes through the center. O. Usually they call circles O. Like people are called John. Circles are called O. And then these are the endpoints. end point, end point. And that's the diameter. Diameter has to go through the center. Right? Yeah. So the center of the circle, given two endpoints of a diameter, is the midpoint of those two endpoints. So that's also you need to know. So you have to know a bunch of stuff about to do this problem. You have to remember a bunch of stuff from geometry, from basic geometry.
Yeah.
So
well, remember what we wrote here. Let's say x1, y1. This is x2, y2. The coordinates of the center. Joel already wrote this, but I'm going to rewrite it.
Yeah.
Because it was critical to solving the problem.
Right.
Take the average.
Yeah.
Of each component.
That's okay. So before we introduce ourselves and go through all the stuff about what we even are trying to do here, why don't we look at the answers? Look at their answer and see how they do it. You would think that they're going to do it in a way very similar to the way we did it. Although it would be interesting to see how they get this, how they figure out if it's 5/2, how they 5/2 or 5/2 or 25/4, because that can be done different ways. So let's see. Okay, I think we get it. Okay, let's see how they did it. Correct. Okay, so let's get a hint. Okay, so what we do is we just keep getting hints. There are 5 steps to this problem. So it's not the easiest geometry problem in the world because it has 5 steps. Now let's just get all the steps, and now we can talk. Okay. They start the same way we did, where you have to write down the general equation of a circle. That's basic. Let's find the center. Beautiful. So then we did that also. Right, great. Okay, great. Now let's find the diameter using the distance formula. Yeah, sure, that's another way to do it. Right. The diameter. Wait. The diameter is 25? No, d squared is... Oh, I see. So the diameter is 5.
Oh. Yes, that's what they did.
The diameter is 5, so the radius is 2.5. Wow. So that's a third way to do it. So that's
they use the Pythagorean theorem to find the length of the diameter.
No, they use the distance formula, which is the Pythagorean theorem.
Yeah.
This comes from...
Yeah, that's a difference. Yes, indeed. That's. But I think our approaches were faster.
Yeah. Well, the problem... The problem with this approach is it gets a little confusing because when you get the diameter, then you have to take half the diameter, and then you have to square it again.
Yeah.
And one would be really tempted. It gets a little confusing when all of a sudden you have this d squared. I guess you have to really keep straight in your head what you're doing, right? You got to get the 5/2, and then square the 5/2. Yeah. But Seth's approach is probably the smartest way, which is such an important concept in algebra, where if you have an equation, a line, a point that's on that curve must satisfy the equation. We already sort of know that subconsciously, but really that little thing really is powerful. If you have an equation and every single point on that curve must satisfy the equation. And that's what Seth used. Such an important, powerful, fundamental concept, which is very often forgotten. And I just was lazy, right? I noticed the pattern that the radius, this is the radius squared. The radius squared, see, this is a right triangle. So it's easy to get r squared because it's 2 squared plus 3/2 squared because of the Pythagorean theorem. So I went directly for the r squared, right? That's a good approach, actually, right? If we are looking directly, if you're doing a problem in math and you want to know what r squared is, where is it? Oh, where is the r? There it is. That's the key, right? We are looking for r squared. right? That try to get it directly. If you could, boom, you could do something to get exactly what r squared is, just exactly the way it is. Try to do that. It's very efficient when you have a problem. Look to see. So we're here. Seth has a PhD in math from MIT. I have a PhD in math from mechanical engineering. Oh God, sorry. Mechanical engineering, PhD from Columbia University. We're here to hopefully show you how to approach studying for the math SAT and how to do specific math SAT questions. Oh, Seth's name is Seth Chaiken. I'm Joel. We see that on the video there. And a good approach to studying for the math SAT is Google Khan Academy SAT practice and take one of their classes, the digital or non-digital class, depending on which SAT test you're planning to take. And in terms of approaching the problems, that's what we try to do. We try to offer different approaches on how to do each math problem. This one, there were 3 approaches to do it. And I love Seth's approach. If a point is on a curve, it has to satisfy the equation of that curve. And my approach really was, if you have to calculate something, try to get it directly. And those are 2 approaches. What do you think, Seth?
Oh, I like it.
Yeah.
I think we covered a lot of relevant ideas and facts.
Yeah. And of course, don't ever forget the Pythagorean theorem when it comes to geometry. Dropping perpendiculars, making right triangles is very helpful in geometry. It comes up a lot. Okay, and we really didn't need the Zeitboard. I don't think, we're not going to need the reference sheet. But the reference sheet, I think, does give you the Pythagorean theorem. But hopefully you know the Pythagorean theorem. So you can try Zeitboard. I don't think this is... Oh, there it is. Wow, look at that. Look at us. There is the reference sheet that you get. And they do give you the Pythagorean theorem on the SAT. So, but you have to know how to use it, right? They give you all this stuff, but if you don't know how to use it, then it's not that useful. Okay, everyone. So I guess that's it for today, right?
Of course, the Pythagorean theorem applies only to right triangles.
Absolutely. That's why I always say, when in doubt, drop perpendiculars and all radii are equal. And when you really get in trouble, look for similar triangles. But usually you don't get into that much trouble at the SAT. Okay, everyone. I guess that's it, right?
That's it.
Okay. Then have a great day, everyone. And, well, we'll see you next time we meet. Bye-bye, everyone.